So to kind of piggyback off of equivalent statements, we now can talk about De Morgan's laws for logic. And so there's a De Morgan's laws for sets. This applies the same kind of idea. So what happens is if you have kind of a combination of different operations, so if I'm doing a negation and an and or an or, I can come up with an equivalent statement that still ends up meaning the same thing. So if I'm looking at the statement P and Q, and then I want to negate it, what I can do is go ahead and distribute that negation, so not P and not Q, but the operation needs to change as well. So it has to flip to or. Likewise, if I start with P or Q, and then I want to negate it, an equivalent statement would still be to distribute that negation, but it has to flip to the opposite operation. So it's essentially like that negation is applied to the operation as well. The benefit of this is if you have a lot of negations going on, it can make your life a little bit easier. So we're going to do an example to show that. We're going to use De Morgan's laws to determine if the statements are equivalent or not. So I could go ahead and I could make a truth table for this and a truth table for this, but that would take a lot of effort. Instead, I can recognize that I have this negation out front of this compound statement. So I'm going to go ahead and distribute that negation. So using De Morgan's laws, this is equivalent to distributing the negation to each piece. So we'd have not P, and then Q gets negated. And then I need to flip that operation up to or, okay? And then from here, I'm trying to see, okay, this end part matches up, but does this from? And if you think about negation, it flips the truth value. So this flips the truth value once, but that flips it back to the other thing. So this statement is equivalent to P or not Q. So without needing to do a truth table, I can immediately see these are equivalent using De Morgan's laws. Okay. Looking now at this next one, ignore that has a highlighter in it, forgot to take that out. That's okay. So what I'm going to do is the same process, but just kind of comparing these to begin with. If I'm using De Morgan's laws, it would have to switch the operation. So this will end up not being equivalent to each other. But just applying that same property, this is equivalent to distributing the negation to the pieces that you have. So this gets negated, this gets negated, but that operation has to switch to end. And then the double negation cancels out, so this is equivalent to P and not Q. And there is definitely no way an or statement is equivalent to the same and. So these are not the same, they are not equivalent. So just way easier than having to use a truth table for all of this. You can, way back up here, use a truth table to show these result in the same thing, but just for time's sake, we're not going to do that. Okay. So let's try now to use De Morgan's laws to just rewrite this statement. We're told it is false that Ariel is a country singer or Jordan sings opera. So you have to be careful with the English language here. We're saying it's false that all of this stuff occurs, okay? So I've got two statements within here. I've got the statement, Ariel is a country singer. So I'm going to call this P. And then I've got the statement, Jordan sings opera. So that will be the statement Q. So in logic form, or in symbolic form, this is, it is false. That's exactly the negation. That this stuff occurs, so I need to put everything inside parentheses. Ariel is a country singer, so that's the statement P. Or is given by a V. And then Jordan sings opera is exactly the statement Q. Okay. So using De Morgan's laws, I can go ahead and distribute that negation. So that would be not P, not Q. And then I go ahead and flip that operation to and. Okay. So now I can go ahead and figure out what is the actual meaning of not P, not Q. And then immediately an equivalent statement would be then putting it back into sentence form. So realistically, not P and not Q still have the same meaning. The only difference is it is Ariel is not a country singer. And then instead of Jordan sings opera, the negation would be Jordan does not sing opera. Okay. So to write this in an actual statement, just to give myself some more room, I'm going to move this up here. An equivalent statement is not P, so Ariel is not a country singer. And Jordan does not sing opera. So both of these sentences have that same underlying meaning, okay? So let's try another example where we're just going to use De Morgan's laws to write an equivalent statement. So we're starting out with not P or Q. Using De Morgan's laws, I go ahead and I just copy down my original statements. I distribute the negation to both of them. And then I go ahead and I need to flip that sign. So the or changes to end. And I don't like this double negation, so this just switches to P and not Q. That is my equivalent statement. For this next one, same kind of idea as the last example. It is not true that the dog or cat want to go outside. So again, it is not true that this stuff happens. So I've got two statements within here. Statement P is the cat wants to go outside. Statement Q is the dog wants to go outside. So the phrase that's given to us, it is not true that, so that's the negation of this statement. The cat or dog want to go outside is P or Q. So using De Morgan's laws, this is equivalent to distributing the negation and switching to end. Okay. So putting that back in sentence form, not P is the cat does not want to go outside. And not Q is the dog does not want to go outside. So again, it's just very convenient for us. We don't have to do as much work. I don't need to do tons of truth tables. I'm just applying this law to make life a little bit easier.